So now we're going to be moving into one of my favorite things ever called the normal model. So you might have heard of something called a bell curve, especially when people talk about grades, and that is really based on what the normal model is. So a normal model is bell-shaped, unimodal, meaning it only has one mode, and symmetric. It looks something like this. So you'll often see the notation capital N parentheses mu comma sigma. And what that means, the N stands for that we're talking about a normal model. So later we'll look at some other types of models and change what letter we have there. And that tells me that I'm talking about this symmetric bell shape. The mu stands for the population mean, aka my center. And the sigma is the population standard deviation, aka my spread. Well, I don't always have my population parameters. So our population parameters are mu and sigma, and they describe the mean of the population and the standard deviation of the population. A lot of times I'm dealing with sample statistics, which would be x bar and s, values that describe the sample mean and standard deviation. So what's important for today is that we're going to learn something called the empirical rule. The empirical rule tells me what percentage of my data is within a given number of standard deviations. So the empirical rule states that approximately 68% of the distribution lies within one standard deviation of the mean. That means between a standard deviation below and above. Approximately 95% of the distribution lies within two standard deviations of the mean. And approximately 99.7% of the distribution lies within three standard deviations of the mean. So here's what that looks like. If you don't have this on your page, then let's sketch this out. So you have this nice bell curve, and then at the bottom we put our z-scores, because what was a z-score but how many standard deviations I am from the mean. So we always put the 0 in the middle, and then we have -1, -2, -3, and then +1, +2, +3 going off to the right. So if we want to find our percentile ranks, it's going to be helpful if I do a little something different with my empirical rule. So the empirical rule states that I have 68% in between my one standard deviation below and one standard deviation above. And if I'm at my median, then that means I'm at the 50th percentile. By the way, notice I'm using mean and median relatively interchangeably, and that's because this is a symmetric distribution. So my mean is not being pulled toward either direction. So that's why it's really important that we have a symmetric distribution for me to be able to use my empirical rule and other values. So I have my 50th percentile. Now, if I have that 68%, it's symmetric, so I can split this in half. So if I want to go down to the left, 50% minus 34 is going to give me 16. And then 50 plus 34 gives me that 84. If we go out another standard deviation, now 95% of my data is included between those two standard deviations. And one thing that's helpful to do is to know that I'm just going to draw another kind of version of my curve over here. Because you don't want to be, when we start practicing this, you don't want to just keep looking at these notes and not learning these values kind of by heart. So it helps to kind of think of these as pieces. So this is 34%, 34%. And then if we do our 95, that takes me for the two standard deviations, minus 68. And that gives me 27. So these are 13.5%. So if I want to go down my percentile, that means from the 16, I'm going to subtract 13.5%, which will give me 2.5 percentile. And then way up at the top, we would add the 13.5. And then if we repeat the same process, now I have 0.15 and 99.85. So memorizing these, so 99.7 minus 95, so 1.35 is here. And then the little 0.15 that we just found. Learning these values I have down here in the bottom right is going to be super, super helpful. That looks so messy, and I'm sorry about that. All right. So if we want to find this probability, so if we want to do our z-score is less than -1. So if I have my 0, -1, then we could look at the percentile scores that we just had. That's really asking what percentile is a z-score of -1, which would be 16%. Or I could know that this whole piece is 50%, and that between -1 standard deviations and 0 is 34%, and 50 minus 34 is 16. So I'm just kind of reasoning through it, but we have it written right above so we can look at it. What about a z-score of greater than 2? So we want to draw our line at 2, shade to the right, but that's not what a percentile gives me. A percentile gives me to the left. So to the left is 97.5%. So 100% minus 97.5% is 2.5%. Now let's find something between two values. So what I want to do first is find the below 1. So my percentile at 1 standard deviation is 84%. At a z-score of -2, my percentile is 2.5%. And when I subtract those, I get 81.5%. When I have or, I need to add my values versus subtract. So a z-score of -1, we said percentile is going to be 16. Then above 2, we found in a step earlier was 2.5. Once again, we did that by finding the percentile, this whole thing, and subtracting that from 100 to get 2.5. And then I add those together to get 18.5.